Basics of spaceflight launch. Upon completion of this chapter, you will be able to describe the role launch sites play in total launch energy, state the characteristics of various launch vehicles, and list factors contributing to determination of launch windows. Mission operations phases. Interplanetary mission operations may be considered in four phases: the launch phase, the cruise phase, the encounter phase, and, depending on the state of spacecraft health and mission funding, the extended operations phase. These phases are actually subcategories of a flight project's Phase A, mission operations and data analysis, each of these mission operations phases, and subjects pertinent to them. Launch vehicles. A Centaur upper stage rocket. The launch of a spacecraft comprises a period of powered flight during which the vehicle rises above Earth's atmosphere and accelerates at least to orbital velocity. Powered flight ends when the rocket's last stage burns out, and the spacecraft separates and continues in freefall. If the spacecraft has achieved escape from Earth's gravitation, rather than entering Earth orbit, its flight path will then be purely a solar orbit of some description, since the launch pad was also in solar orbit. To date, the only practical way to produce the propulsive energy needed for launching spacecraft from Earth has been by combustion of chemical propellants. Mass drivers, however, may be useful in the future for launching material from the moon or other small airless bodies. Launch engine propulsion, whether powered by photovoltaics or nuclear reactors, is useful not for launch phase, but for gently but steadily accelerating spacecraft that are already in Earth orbit or beyond. There are two groups of propellants for chemical combustion rockets: liquids and solids. Many spacecraft launches involve the use of both types of rockets. For example, the solid rocket boosters attached to liquid-propelled rockets. Hybrid rocket engines use a combination of solid and liquid propellants. Solid rockets are generally simpler than liquid, but they cannot be shut down once ignited. Liquid and hybrid engines may be shut down after ignition and, in some designs, can be reignited as needed. Expendable Launch Vehicles (ELV) are used once. The U.S. Space Transportation System (STS) or Space Shuttle was designed as a reusable system to reach low Earth orbit. Most of its components were refurbished and reused multiple times. Upper stage rockets can be selected for placement atop the launch vehicle's lower stages or within the shuttle's cargo bay to provide the performance needed for a particular payload. The Centaur high-energy upper stage has been a choice for robotic missions to the moon and planets for many years. A sampling of launch vehicles of interest to interplanetary mission follows. One useful measure of performance for comparison among launch vehicles is the amount of mass it can lift to geosynchronous transfer orbit.